Alright, so we'll take a look at binomial and geometric distributions. Quick introduction. So a binomial distribution, and then if you've ever seen Price is Right, actually we'll look at how Plinko is actually a binomial setting. So very quickly, the quick rules to a binomial setting: 4 rules. Each trial has 2 different outcomes. Either there's a success or there's a failure. There's a fixed number of trials, so we have a certain number of times that we're going to do something. Each trial is independent. Now, this is an important part. This is where all of a sudden, if you're playing some kind of card game, that's out. Or a lot of the settings we saw where we didn't replace the previous information, that's going to be out, because as you take something out of the group, you're changing probabilities, which means that one thing is affected by the next. So this independence is going to be important. And again, independent means one thing does not affect the other. And then the fourth thing, the probability of success must be the same. So again, that's the same. It's very similar here in that when we did the non-replacement, probabilities were constantly changing. So kind of put this into an example that maybe if you've seen Price is Right, people go nuts for Plinko. So when you put the chip in, right, it can bounce left or right each time as it goes down and then lands in a spot. Person wins however much money. Well, here this is binomial because there's 2 potential outcomes. Every time it hits, it can either go left or right. If you look, there's 6 different bounces, right? There's 1, 2, there's a third bounce, a fourth bounce, a fifth bounce. So there's 6 different pegs that it can bounce off of. So that will not change regardless of which way it bounces. It always has to go through 6 rows. Each one is independent, right? Where it bounces the first time, if it bounces right, it's not going to affect whether or not it bounces right or left again. Each time it bounces is independent, and it's a 50-50 shot either way. Regardless of which way it bounces, that's never going to change. So because of those 4 things, right there in red, you can see that this is a binomial setting. So let's say that you're a soccer player, you make 75% of the penalty shots. What's the probability I make 5 or fewer in my next 9 attempts? We're not actually going to answer the question. We're just going to look at, is it binomial? So number 1, are there 2 outcomes? Is there a success or failure? Yes, there is. You either make or you miss the penalty shot. All right, so there's number 1. Number 2, right? If we go back, is there a fixed number of trials? In this particular case, yes. N equals 9. Number 3, each shot is independent, right? Whether um, and then the probability that you make a shot, um, we can see right there the probability of a make is right there. That doesn't change. Obviously, with practice and whatnot, it could, but when we make one shot, there's no kind of replacement here. So this is binomial because of that situation. All right. So a geometric setting, very similar. Again, success or failure, yes. Same thing we just saw. The probability of success is the same for each observation. So again, you can't do something without replacement. Each trial is independent, but right here, number 4 is where it's different. The variable of interest is until success, right? And until success. So this is what's going to separate a geometric setting. A quick example, if you want to look at it. Here's one. 80% of the residents on this particular island in Hawaii are actual native Hawaiians. Suppose you fly in there, what's the probability of the first villager you meet? Right? So that's saying that we have success right off the bat. And then a second example, what is the probability you don't meet a Hawaiian until the second villager? So right away we can see, right, there's, go back to your, so are there 2 outcomes, right? There are 2 outcomes, excuse me. You meet or don't. All right. 2, the probability that you meet equals 0.8, and that's not going to change. 80% of the folks are, so you meet someone, you move on, you meet somebody else. We're not taking someone out of a bag or a box, kind of like we did last time. Each person is independent, right? Each person is independent. And then here, number 4, it's until success. So you can see right away, first villager, so that first example, right, what is the probability of the first villager? So in part A, if you want to think about it this way, the until success there, well, that's going to be n equals 1. And then for part B, the until success, sorry, it'd help if I spelled right, until success in part B, that second question, would be that n equals 2. So what sets this apart from the strictly binomial setting is a binomial, we're going to say, you know, n equals this out of so many people, out of so many trials. Versus geometric, we don't know how many trials. It's not set until success. And then one more example. Assume that you make a sales call about 19% of the time. So find the probability that you make your first sale on the 5th call. So there it is, until success. Right? And then we can get a little bit more in depth with it. Let's just look at this. Is it a geometric setting? So number 1, are there 2 outcomes? And that would be, yes, you either make sale or you don't. All right. For a geometric setting now, the probability each time, the probability of a sale is 0.19. Each call, right? If you have success on one call, doesn't mean that you're going to have success or not have success on the previous call. Each person you call is going to have a different view of you as a telemarketer, I guess. 19% is pretty good for telemarketers. I would think it'd be somewhere near 0, considering nobody ever wants to talk to them. But anyway, for this particular example, each sale is independent. And then that final part for number 4, are we going until success, right? So we make our first on the 5th call. So we're going to keep calling until success, right? You make your first sale on the 1st, 2nd, or 3rd call, right? So it's the first sale. So we keep going until success. So again, right here, until success. So for part A, that'd be n equals 5. For part B, that'd be n equals 1, 2, or 3. And we'll see as we get more and more into this that a lot of those probability rules are going to come right back. And then for part C, you don't make a sale on the first 3 calls, so that would mean that n has to be greater than 3. As we get into how to start calculating this stuff over the next few days, it's just going to be important that we make sure that we know when things are binomial, when things are geometric.